What's up, everyone? Welcome to the video. So I wanted to give you a video on balancing redox reactions. This is a topic that we spend a decent amount of time on in chemistry, so I want to make sure that we have a good clarification on what we're doing here. So when we're balancing redox reactions, things are going to look a little bit different than what they have been looking like thus far in this unit. Our equations aren't as clean looking, but we're still balancing. It's not simple as just counting the number of atoms, making sure it's equal on both sides. We have to deal with a few extra steps, and here are all 7 right here. I'm not going to go through each individual step right now, but we'll go through them as we tackle our first example. So let's go ahead and start off right away. So we're looking at this equation, and as you can see, it does not look anything like any of the other equations that we've been balancing in this unit. We've got ions on one side, we've got elements and compounds on the other, and it looks a little bit weird, but when we go ahead and break this down into steps, things start to look a little bit more normal. So let's start off by identifying oxidation numbers throughout the compound. So we know that looking at a compound, the overall charge for this compound is 0. So the net charge over here is going to be 0, with oxygen having a -2 and lead having a +2. Anytime we have lone elements, the oxidation number is 0, so over this I2 output is 0. Now this lead ion has a +2 charge, so the oxidation number is +2. And then over here, this iodate ion, the overall charge is -1. Oxygen always contributes, it has a -2 oxidation number, so that means overall it's contributing a -6 oxidation state. And in order for this to equal out -1 overall, that means that iodine is going to have a +5 oxidation number, because +5 minus 6, +5 minus 6 gives us a -1. So iodine has a +5 oxidation number in this iodate ion. All right, so now what you want to do is break it into half reactions. I see here that PbO2 goes from PbO2 to a lead ion. So we're just going to write that on this side, and that's our 1/2 reaction. We have lead is decreasing in charge. I actually found an error right here. So this should be +4, and then this would be -2. So lead is going from a +4 to a +2. So it is gaining electrons, meaning that it is reducing. Now over here, I've got my iodine, I2, going from a neutral charge to a +5 charge. So it's losing electrons, meaning that it is being oxidized. But I'm just going to write this IO3 -1. So here's my 2 half reactions. As you can see, we have one reaction on top, but we split it into 2 half reactions, so we can kind of see what's happening with each species as we go through this redox reaction. My first step is my second step rather, is to balance everything that is not oxygen or hydrogen. So I see here I have 1 lead and 1 lead, so this is balanced. And over here I see I have 2 iodine and I only have 1 over here. So in order to balance that, I'll put a 2 coefficient right in front of the iodine to make sure that we have 2 on both sides. So that's good and dandy. Next step, we want to balance the oxygens using a water molecule. So for every oxygen I have, I need to add a water molecule to the other side to make it balanced. I have 2 oxygens over on this side, so that means I'm going to have to add 2 waters to this side, 2 H2O. So now I have 2 oxygens and 2 oxygens. Now on this side, I have 2 times 3 oxygens. So that's going to give me 6 waters. So I have to write 6 H2O on this side in order to balance out my oxygens. We see how we have 6 here, 2 times O3, that gives me 6. So I need to balance it out with 6 H2Os. All right, once we have balanced out the oxygens, we now want to balance out the hydrogens. And the way that we balance out hydrogens is by using hydrogen ions. So if I look up here, over on this side, I have 2 times 2, which is 4. So in order to balance out those hydrogens, I need to add 4 H+ ions to this side of the equation. And that's good and balanced, 4 and 4. So down below on this second half reaction, I have 6 times 2, which is 12. So I'm going to need to add 12 hydrogen ions to this side. 12H plus. 12 and 12, so we're good there. After we balance the hydrogens and the oxygens, now we want to balance out the charges. And the only way that we can balance charges is by adding electrons. So I'm going to look at the net charge on either side of this first half reaction. I have 4 hydrogen ions which are contributing a +4 charge, and I have 2 lead ions which are contributing a +2. Now, like I said, all we can add are electrons, which are going to decrease our overall charge. So I don't want to add any to this side because that's just going to get me further away from getting it more even. That's going to make it less even. So if I want to turn this 4 into a 2, I need to subtract 2, which means I need to add 2 electrons. 2 electrons is going to now make this +2, which is equal to this +2 on this side. All right, we'll move on to this side now. So I have neutral charge on this side. There is no charge because I'm dealing with just compounds. Now on this side, I have 2 times -1, so that gives me a -2. And then I have 12 pluses, so that's going to give me a +12. So my net overall charge is +10 on this side. And I'm going to need to make it 0. In order to make it 0, I need to add 10 electrons. And that should balance out this charge to make both sides be 0, which it does. All right, we've balanced out hydrogens, oxygens, we've balanced out the charges. Now we need to make it so that we multiply our equations so that we have the same number of electrons in each. So I have 10 on my second half reaction, and I have 2 on my first half reaction. The only way that I can make it so that I have 10 is to multiply everything by 5, put it in parentheses, just like in math, we distribute the 5 all the way across. So that's going to make this 10. That's going to make this 20. That's going to give me a 5 PbO2, 5 lead ions, and 10 H2O. So I have 10 electrons now. I have 10 electrons here, so I don't need to change anything down below. We're just going to keep it the same. And now, next final step, we just have to cross out the repeats on both sides. You should find that we will usually only be crossing out our electrons. The electrons are what we want to be crossing out. And once we've crossed out everything that's repeated, we should now be able to write our final equation. So I'll go ahead. We have this crossed out, so I have 20H plus 5 PbO2 plus 6 H2O and plus I2. Draw my arrow, and then I want to write everything that isn't crossed out on this side. So that's going to give me 5 Pb ions, 5 lead ions, plus 10 H2O, plus 2 IO3 minus, plus 12H plus. And once it's all said and done, this right here, this long equation with all these ions and stuff is my final equation. You could always go through and count the total number of each element that we have on both sides, and that should give you and if it's equal on both sides, then that means that it's correct. So hopefully this helps. Took you through the steps for one example equation. If you have any questions, please leave a comment below. Until next time, I will catch you later.